triangle that is not a right triangle. So we've been using trig to solve for sides and angles in right triangles. In a right triangle, we can say we have a hypotenuse, so we could do things with SOHCAHTOA, opposites, adjacents, and hypotenuse. But a hypotenuse is a distinct characteristic of a right triangle. So if we have a triangle that is not a right triangle, it does not have a hypotenuse, and we can't do SOHCAHTOA stuff. So we need a different method, and that's what the law of sines is about. To solve for missing pieces in a triangle, you need to know the measure of at least one side and two more things. They could be sides or angles, but you have to have at least one side and two more things. Sometimes we can solve using what is called the law of sines, which is what we are talking about today. The law of sines is this formula. It does not need to be memorized, but it probably will be by the end of your homework because you're going to use it on every single question, and it's not that messy of a formula. So remember how we name a triangle? The sides have small letters, the angles have large letters, and they're across from each other. So side A is across from angle A, side B is across from angle B, side C is across from angle C. So our law of sines formula, what we're going to do is set up a matching pair of sides and angles with the sine of the angle over the length of the side. So to solve using the law of sines, we have to know both parts of one letter, both an angle and a side for one given letter. So to start each question, I create a list of the 6 parts of a triangle and what I know so far. So I know angle C is 103, I know angle B is 28, and I know side B is 26. So I have 3 more things to solve for. The first thing to solve for requires no trig. What can I solve for right away? Angle A. What do we know about 3 angles of a triangle? They have to add up to 180, so I can find that third angle by subtracting what I already know from 180. And that leaves 49 left over for angle A. So now I have 2 sides to solve for, and we're going to solve for those by using the law of sines. The law of sines says that we need a matching pair, so we need to know both parts of one letter. So we know both parts of letter B here, so that's where we're going to start. Sine of angle over matching side. It's always sine of the angle on the top and then the side length on the bottom. Equals, and then we can pick either other piece of information to start with. We'll have to do them both, so it doesn't matter which. So I'll just go alphabetically and do sine of 49 over A. So on the top is the sine of the angle, on the bottom is the length of the side. How do we solve stuff that looks like that with the 2 fractions? Cross multiply. So that gives me A times sine 28 equals 26 times sine of 49. And I'm trying to solve for A, so how do I get A alone? Divide by the sine of 28. So on the calculator, we want to type in 26 sine of 49 divided by 28, sine of 28. It is important that you close parentheses. So when you enter this in your calculator, you're going to type in 26, press your sine button, and when you do that, your calculator opens up a set of parentheses when you press a sine, cosine, or tangent button. You need to close that off after you type in the 49. Then divided by sine, and it opens it up, and you need to close it up after you do 28. If you are using a cell phone calculator, this is much more difficult to plug in. It's doable, but I will have to help you with how to plug it in later. What do we get when we do 26 sine 49 over sine 28? 41.8. About 41.8. Then we have one more piece of information to solve for, and we are going to solve for it the same way. I I go back to the beginning pair of 28 and 26. Just in case that last answer was wrong, I don't want to use it if I don't have to, because then everything will be wrong after that. So I go back to the starting pair, and this time I do sine of 103 over c. So we always want a matching letter on top and bottom. Angle on top, side on bottom. Cross multiply. So we get c sine 28 equals 26 sine 103. And divide by everything that is with that variable so that we get it alone. Again, when you type it in, you need to make sure that you're closing parentheses around those angle numbers. So what do we get for side C? Right about 54, 53.96, right about 54, 53.9. There is no quick way to check your answers and make sure they are correct, but there is a quick way to make sure that they are not incorrect. What do we know about angles and sides in a triangle? The angles add up to 180. What do we know about an angle with its partner side?
If it's the biggest angle,
The biggest angle should match with the biggest side, and the smallest angle should match with the smallest side. It's something that we learned about triangles a while ago. So what we can do is do a quick double check and make sure that our biggest angle matches with the biggest side. So angle C was the biggest angle, side C turned out to be the biggest side. That's a good sign. Then check the smallest one. Angle B was the smallest, side B was the smallest. That's a good thing. It does not guarantee that our answers are right. But if they don't match up, your answers are wrong. Okay, so just the fact that they match up is not enough to guarantee that your answers are right, but you know if you do this and your biggest angle is not matching with the biggest side, your answers are definitely wrong. Okay, so it's just a good double check to make sure that our answers are plausible. Let's do another example. Let's try again. Okay. So I start by listing what I have and need to find. So angle B is 118, angle C is 36, and side C is 14. What can I find first? Angle A. How do I find angle A? Add them up and subtract from 180. Three angles of a triangle have to add up to 180 degrees. So add up what we have, subtract it from 180, and that leaves the leftovers of 26 for angle A. Then, since we know both parts of letter C, we can apply the law of sines. In every one of your problems today, you should know both parts of one letter. If you don't, you can't use the law of sines. Then we have to do something different that we'll talk about tomorrow. So I start with the pair where I know both parts, sine of 36 over 14. And I set that equal to another pair. It doesn't matter which one because we're going to have to do them both. So sine of 26 over A. Cross multiply. So I get A sine 36 is 14 sine 26. And divide by what is with the variable to get it all alone. So in the calculator I do 14 sine 26 divided by sine of 36, remembering to close off parentheses after those angles. And what do I get for side A? And about 10.4. We will go to the nearest whole number for angles and one decimal place for sides to just be consistent in our rounding. So angles go to the nearest whole number and sides go to 1 decimal place. We still have one more side to solve for. To do that, we apply our law of sines again, going back to the original pairing of sine 36 and 14, but this time using the 118 with b. Cross multiply. And divide out. So what do we get for side B? Right about 21. Okay. We can do our quick check then to make sure these answers are plausible. Biggest angle is B. Biggest side should be B, and it is. Smallest angle was A. Smallest side was A. So it doesn't guarantee our answers, but it's at least a good double check. If it doesn't line up, your answers are definitely wrong. Questions? When we studied congruent triangles a long time ago, we learned about things like side, 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 angle, side, angle. But we learned that SSA was not a congruence method, partially because it's a bad word. So SSA never worked for congruent triangles. It can create a the information that we're given is 2 sides and an angle that's not between those sides. Sometimes we end up having no triangle at all. Like those values actually will not close off to make a triangle. Sometimes values might close off and make one perfect triangle. Sometimes it might happen that we could actually get 2 different triangles with those values. So this is called our ambiguous case because kind of weird things can happen sometimes. In this class, we will only explore the case of one triangle. So for all of our questions, we will just get one answer, and it will be the same for everybody that way. If you go on at some point in a later class, you'll look at how those other possibilities can occur. But for us, we will look at just the case where we end up with one triangle. So I didn't really leave myself any room to work here, so I'll go to a blank screen. We're going to begin by listing out what we were given in example 3 there. So that was side, let's see, angle C is 122, side A is 12, and side C is 18. We cannot start this problem the same as we were starting the other ones. We began the other problems by subtracting from 180 to get a missing angle, but we only have one angle this time. So we can't subtract from 180 to get a missing angle. But we do know both parts of one letter, so we're going to start this problem with the law of sines. So I'm going to set up sine of 122 over 18, the pairing that I know both parts of. The only other thing I know at this point is 12, which is a side, and sides have to go on the bottom, so that 12 has to go on the bottom. 12 matches with angle A, and we always want sines of angles, so sine of A goes on top. We could solve this by cross multiplying, but that's more than what is necessary. Since our variable is on the top, we can just multiply both sides by 12, and that will clear off the bottom of that fraction. Then we can type 12 sine 122 divided by 18 into the calculator. And when I do that, I get 0.565, which seems like kind of a strange answer for an angle. And that's because this is not our answer for an angle. What's left on the other side of that equation is the sign of A still. It still says sign. It's not just A over there. It's the sign of A. So how have we learned to solve for an angle? What do we need to do when we're solving for an angle? Use the second button. So what we need to do on the calculator now is the second sign of that decimal that we got. Go to several decimal places. Do not round it off. I'm thinking when I say several, like at least 3, if not 4 or 5 decimal places. If you round it off, your answer can and likely will be significantly different than other people's answers, even though you did stuff right. Okay, rounding can make a really big difference here. So go to several decimal places when you're doing this. So second sign of that decimal gives us the answer for angle A, which I got is about 34.4. But if we're going to go to the closest, we'll just say it's 34. Okay. Questions on that? What can I do to find something now? So I got to find one of the parts of B. What can I find?
You can find out the big B by subtracting whatever 122.
Yep, so we've got 2 angles now. So now we can subtract from 180 to find our third angle. So 180 minus 122 and minus 34 leaves right about 24 degrees for angle B. And then to solve for side B, we're going to go back to our law of sines. Setting up the original pair of side C and angle C again. And the pair for B. We'll see if it catches up here. No, it just disconnected. Okay. We'll try again. There we go. Okay, so I set up the original pair of C, and then now I'm going to use that 24 to find the one last missing thing, the B. Cross multiply as we did in the first example, so I get B sine 122 is equal to 18 sine 24. And divide by what is with the variable. (18 sine 24) divided by 1 sine of 122 gives what for side? For side B. About 8.6. And then we can do our quick double check. Biggest angle is B, biggest side is B, smallest side is B, smallest side is B. See that it's right, but at least is some strong. Questions? Try example 4. I need to know. So we know angle C is 96. We know side A is 17 and side B is 19. Then, to solve for A, we can get rid of the denominator by multiplying both sides by 17. So we type into the calculator 17 times the sine of 96, making sure to close off parentheses after that 96, divided by 19, and that gives me a decimal of about 0.8898. That is equal to the sine of A. Whenever we are solving for an angle, we need to press second on the calculator. So this is where we would type into the calculator second sine of the decimal we got for our last answer to several places. Do not round that off very much. Put in a lot of them. And when we type in second sine of 0.8898, what do we get for angle A? Right about 63 degrees. Now that we have two angles, what can we do next?
Find the big B.
Find the capital B, the big B angle, by subtracting from 180. So 180 minus the two angles we already have leaves 21 left over. And to solve for side B, we go back to our law of sines, setting up the original pair with the 21 that we just found to find little b. Since the variable's on the bottom, we need to do the full cross multiplying here. So we're going to do b sine of 96 equals 19 sine of 21. And to get b alone, we're going to divide by the sine of 96. So in the calculator, I type in 19 sine of 21, making sure to close off those parentheses, divided by sine of 96. And what do I get for little b?
7.
Right about 7, 6.97. Make sure that big matches big. C is the biggest for both, and small is small. B is the smallest for both. Okay. Questions? One more thing to talk about today, and that is area. When you are finding the area of a triangle at some point in a math class, you have learned that for a triangle, area is equal to 1/2 base times height. In our questions today, though, we are going to be given one side, another side, and the angle between them, which is not the height, and we need the height. So what these formulas do, and they do not need to be memorized, these formulas calculate the height of the triangle for you by using a sine. Okay? The formulas match up so that in all of them they have that 1/2. That's the same as the 1/2 and 1/2 base times height. One of these letters is our base, and the whole rest of it is calculating that height. All of the formulas are the same, the letters are just shuffled around. By letter, you need every letter represented. So you need two sides and you need the other angle. So if you have A and C, you need angle B. Them. So what we can do is say that area is equal to 1/2 side times side times sine of angle. We just type that all straight into the calculator. And what do we get for our area? Right about 6.1. And for the last example again, we have two sides and the angle hinge that connects them, so we have what we need for our formula. So area is 1/2 side times sine of angle between. We plug that all in, and we should get right about 20.6. Your homework is the next page of your packet. Do not do it on that page, because then you would need to rip it out and hand it in to me, and the next notes are on the back of that, so that would be a bad thing. So do it on a regular notebook paper. Make sure you notice that the first 7 problems you're solving for all the missing pieces, like our first 4 examples, and the last 3 you're finding area, like our last 2 examples. When you find an angle, round to the nearest whole number. When you find a side, go to 1 decimal place.